是科学家。
比尔是科学家。
比尔是科学家。
科学定律。
比尔是科学家。
惯性是物质的性质之一。
比尔是科学家。
倒数7秒，计时开始。
比尔是科学家。
Matches. You've probably seen one before. They're thin, with a red tip. If you strike it, So how does this work? Let's find out. A match head is made up of a number of ingredients including potassium chloride, sulfur, and powdered glass. The striking surface is made up of sand, powdered glass, and red phosphorus. When the match head is rubbed on the striking surface, some of the red phosphorus in the striking surface is converted into white phosphorus, which reacts with oxygen to ignite. The heat also reacts with the chemicals in the match head, which creates fuel for the fire. Now, you'll notice that when I just touch the two parts, nothing happens. So why doesn't it burn? This is because of this thing known as activation energy. In any chemical reaction, there is an activation energy. If this energy is not reached, the reaction doesn't happen. So what changes when you strike it? Ever rub your hands together to keep warm? The reason it's hot is because of the friction that causes heat. In this case, the friction of striking the match gives off enough heat to surpass the activation energy of the reaction, which is then surpassed by the released heat of the actual reaction itself, therefore causing the match to burn.
Wow.
Combustion, or burning, is a chemical reaction that involves heat and light. A chemical reaction generally is the process of breaking and reforming intramolecular bonds. In a reaction, when bonds are broken, energy is absorbed. The specific amount of energy that absorbed is called the activation energy. And also in a reaction, when bonds are formed again, energy is released in the form of light and heat. And the total amount of energy in a reaction is categorized by delta H. There we go. And what is delta H? Delta H is the total energy of bonds broken minus the total energy of bonds formed, which is also known as the molar heat of reaction.
Measured in kilojoules per mole.
Yo,
Ethan, what's Sujit doing?
I don't know, I wonder.
Yo, Sujit, it's your turn. Sujit? Yo, Sujit.
Oh, well, wait, what? I was just looking up chemistry.
Hello, America. And you know, this is a problem. And we need someone to help fix it. We need America. We need you. It's every day, bro, with that AP Chem, though. Getting 5s on the AP test, it's so easy, bro. Passed all the competition, man. Mrs. Kim is next. Man, I'm flipping through the text, gonna go and ace that test. And I'ma bring in all my friends and make them ace too. This is group 9, boys. Who the heck are flipping you?
Did you know that all the matter and energy of the universe is becoming more chaotic and disordered? That's a fun thought. This disorder and spreading of matter and energy is known as entropy, and is increasing throughout the universe. In chemical reactions, entropy is, well, the spreading of matter and energy. Delta S is the measurement of entropy in a reaction and is measured in joules per mole Kelvin. The way entropy can increase in a reaction can be determined with the changes in states of matter. Solids have very little entropy since their molecules are close and tight, while liquids have some entropy since their molecules are looser than solids, and gases have the most entropy because gas molecules are very spread out and disordered. So in a chemical reaction, when there are more moles of gas on the product side of reaction, entropy increases.
So we know that combustion reactions, such as in match lighting, produces energy. We can use this energy to apply work on a system. This work or energy that is put into or out of a system is known as Gibbs free energy, indicated with the symbol delta G. To calculate delta G, we need to know the heat of enthalpy in kilojoules per mole, the entropy of the reaction in kilojoules per mole Kelvin, and the temperature in Kelvin. Then we can use the equation delta G equals delta H minus temperature multiplied by delta S. When delta G is positive, work is done to make a reaction proceed, meaning that the reaction is a non-spontaneous process. However, when delta G is negative, work is done by the system, and that the reaction will not require energy to proceed, meaning that the reaction will be spontaneous. So why is this important? Well, we can use chemical reactions such as a combustion reaction to power cars, create electricity, cook our food, heat our water, as well as many other things.
Hi, my name is Leopold Kim, and I've been addicted to burning matches since I was 15 years old. Number 15. Addiction to lighting matches. The last thing you want in your family is someone else's match addiction. But as it turns out, that might just be what you get. A YouTuber known as Ethan Doan uploaded a video to a site showcasing his friend lighting matches all the time with the statement, "This is the friends you have in AP Chemistry." Admittedly, he was using safety matches, but that's even worse. Combustion, fumbustion, combustion, fumbustion, combustion, fumbustion, combustion, fumbustion. Here we go.
Call me MC Delta T cause I be spitting fire. Got my hydrocarbons burning hot in the fire. All these people be burning it the same. I be using matches like I'm part of the chem gang. Yep. They all non-polar, got 1 mole of propane, mixing it up with some excess oxygen. I'm so lonely cause I got single bonds, 347 kilojoules per mole. That's so hot, yeah. My boy Ethan on the track. We're gonna go.
My bars are too extraneous, call me spontaneous, cause I got free energy. Autos equals delta G, pull up in Beverly, doing my chemistry cleverly, got a lot of entropy. This was complimentary.
Hope you survived the cringe.
Yeah.
Great.